Hey everyone. So the next topic that we are looking at is this idea of energy efficiency, which is basically asking the question, how much useful energy do we actually get from something? So the way that we can calculate efficiency when we're dealing with energy is that the total amount of efficiency that we get for an energy resource is going to be equal to the amount of useful energy that we have divided by the total amount of energy that is in that resource. And then since that's going to get us a small fraction, you can just multiply that by 100, and that'll get us to a percentage. Now, this seems like kind of a strange equation to just kind of throw at you, so let me give you an example. So the average incandescent light bulb here. Here's a light bulb. Oops. Try that one more time. All right, here's our average incandescent light bulb, right? It's gonna shine, we get, light coming out of this thing. They are much less effective than you would actually think. So if we have 100 joules of energy coming off of a light bulb, or that's going into a light bulb, I should say, what happens is you get 10 joules of light coming off of this, which is what you want, and you get 90 joules of heat. And if you've ever touched a light bulb that has been on for a while, heat, there we go. If you've ever touched a light bulb that's been on for a while, you realize it gets really, really hot. And the longer that you leave it on, the warmer it becomes. That's because most of the energy that's going into these old light bulbs actually becomes heat, not light. So if I wanted to plug this into my equation above, I would say that I'm getting 10 joules of useful energy divided by 100 joules of total energy, which is going to be 0.1. So if I multiply that by 100, I get, this is a 10% effective light bulb. So that's one way that we can kind of look at efficiency, is that it's the amount of energy that's actually the type that we want versus the total amount of energy that you have. Another good example of this is car engines. Car engines run on gasoline. You get a certain percentage of energy that actually goes to driving the car forward. And then you get the rest of that engine is going to be, producing heat, producing sound, all these kind of extra energies that take away from our total efficiency. So car engines are not 100% efficient. We lose energy, or it creates energy that we really don't want with it. And so this is just kind of a good example of talking about how we can calculate the total efficiency of something. Now, we can visualize the efficiency of an object fairly easily, and we're going to use a diagram to kind of show off how this energy works. And so these are called Sankey diagrams, and I'll go ahead and create a new page for this one. Let's do a Sankey diagram for that light bulb. So again, I've got kind of this light bulb here, and we know from the previous slide, our light bulb is only 10% effective. Here we'll have some light coming off of it. And so we know that for every 100 joules of energy that we put in, we get 10 joules of light, and we have 90 joules of heat. And so if I wanted to represent this in what's called a Sankey diagram, what that is it's a large arrow. And so I'm going to go ahead and I'll pick red for my arrow. And when you're drawing your Sankey diagram, some of your arrow goes straight ahead, and that's energy that's really useful. So this is my energy from light that's going to go over here. And the rest of the energy that we have is waste energy, and we say that that's kind of angle off. Now, you can angle it off downwards, you can angle it off sideways, or kind of upwards, I guess. Sideways is going straight ahead. And this is going to be our waste energy. So if I have my 90 joules of heat, that's waste energy. It's not being passed on. It's not being useful. And here's my 10 joules of light. This is the stuff that I actually want. And the base of the arrow, kind of the widest part of that arrow, this is going to be our total amount of energy. So this is 100 joules. 100 joules. And so this is what we refer to as a Sankey diagram. And it's just a way for helping us kind of visualize the efficiency of a source of energy. So again, anything that's kind of going away from straight ahead is our wasted energy, and then anything that's kind of keep going in the same direction as the arrow, that's our energy that's actually useful. So this is two different ways of kind of dealing with the idea of efficiency. We can calculate efficiency using the equation that I gave you, and we'll be looking at kind of the efficiency of different energy resources. And then if you want to visualize that, you can use a Sankey diagram like this.